Hello everyone, welcome to Basics e-Learning. I am going to solve Cbse Ncert textbook for class 10 with a detailed explanation for all the chapters. Today we are going to see trigonometry introduction part. From Cbse Ncert textbook for class 10 we have 4 topics in trigonometry chapter. These are like this. They're like trigonometric ratios and ratios of specific angles, and then we have complementary angles, and the last one is trigonometric identities. So in this textbook we have 4 exercises based on these 4 topics. Now I'll explain about the basics here on the exercise 1, that are the formula that are needed for solving exercise 1 here. They are trigonometric ratios. So there are basically 6 trigonometric ratios. All trigonometric ratios are related to a right angle triangle as I explained in my previous video. Let us consider this right angle triangle ABC. So you have 3 sides and 3 angles for this right angle triangle. In a right angle triangle, one angle is 90 degree and the other 2 angles that are here, angle A and angle C, are less than 90 degree. That is, we call them as acute angles, and the sum of angles A and C should be equal to 90 degree to make the sum of the angles in the triangle making it to 180 degree. So there are 3 sides here, AB, BC and AC. The side that is opposite to 90 degrees, that we call it as hypotenuse. And here this we call it as base, BC. And the other side, that is for this 90 degrees, whatever you are drawing the up straight, this we call it as perpendicular. So the 3 sides of the triangle are perpendicular, base and hypotenuse. Before starting the topic, we should know the Pythagoras Theorem, where we are using this Pythagoras Theorem throughout this chapter. That is, hypotenuse square is equal to base square plus perpendicular square. Or else we can call it as hypotenuse square is equal to side square plus side square. In general, we take the perpendicular and base as the 2 sides of the other 2 sides of a triangle. So now I'll explain the trigonometric ratios here. As I said, there are 6 trigonometric ratios. They are sine, cosecant, sine, cosine, tangent, cosecant, secant and cotangent. So these are the 6 trigonometric ratios. Now I'll explain how these trigonometric ratios are defined on a right angle triangle. So for this I am considering one right angle triangle ABC, where B is 90 degree here. So this we call it as a hypotenuse, and let us take one C, angle C, as some theta, the acute angle where I am considering to define all these trigonometric ratios. So for angle theta, this side will be your adjacent side. The side that is opposite to angle theta, we call it as an opposite side, right? So now sine of angle C is defined as opposite side to angle A divided by hypotenuse. So angle C. What is opposite side to angle C here? AB. So that is given by AB divided by hypotenuse here is AC, right? So now cos C is defined as adjacent side of angle C divided by hypotenuse. What is adjacent to angle C here? BC divided by hypotenuse is AC. Next, tan C is given by, here tan is defined as sine by cos, or else I am writing it as here sine angle C, sine C divided by cos C, or you can write opposite side defined as opposite side divided by adjacent side. So opposite side of angle C is AB and adjacent side is BC. That I am writing here it as AB by BC. Then cosecant. Cosecant C is given by 1 by sin C, which is nothing but hypotenuse divided by opposite side. So hypotenuse is AC and opposite side is AB. Similarly, secant C is given by 1 by cos C, which is nothing but hypotenuse divided by adjacent side. So hypotenuse is AC, adjacent side here it is BC. Then cot C. Cot is nothing but 1 by tan C, which is nothing but adjacent side divided by opposite side. See, from the picture adjacent side is BC and opposite side is AB. Suppose say if you are asked to define the trigonometric ratios for other acute angle, that is for angle A, these ratios will vary. That is for angle A, opposite side will be BC, adjacent side will be AB, right? So sine of A, sine A will be defined as BC divided by AC and cos A is given by adjacent side AB divided by hypotenuse AC. That is the difference here, right? So this is how the trigonometric ratios are defined for an acute angle in a right angle triangle. Now I will explain two methods to remember the trigonometric ratios in simple way. The first method is like this. Hypotenuse, base I am writing. So this is sine, cos, tan and cosecant, secant, cot. So here sine and cosecant are reciprocal to each other, cos and secant are reciprocal to each other, tan and cot are reciprocal to each other. Sine is given by perpendicular divided by hypotenuse, right? That is opposite divided by hypotenuse. Cos is base divided by hypotenuse. Tan is perpendicular divided by base. So this is one table that you can remember. The other one is magic hexagon. So I am drawing one hexagon here. Hexagon, it has 6 sides and 6 corners, right? In all the 6 vertices I am writing the 6 trigonometric ratios: sine, cos, cot, cosecant, secant and tan, right? Now join the opposite vertices of the hexagon, right? Now if we join here, sine and cosecant are reciprocal to each other, cos and secant are reciprocal to each other, tan and cot are reciprocal to each other. The same hexagon we are going to use for remembering the complementary angles and also to remember the identities, trigonometric identities also. The same pattern we are going to draw. As of now, for the introduction part or the formula to remember for solving this exercise 1, I am explaining only the ratios here. So sine and cosecant are reciprocal, secant and cos are reciprocal, tan and cot are reciprocal. Then we will see the ratios. Starting from tan here, move in the clockwise direction here. Tan theta is equal to sine theta by cos theta, which we have already defined. Then sine theta is equal to next to cos by cot, cos theta by cot theta. Then what is cos theta next? Other two, cot theta by cosecant theta. Similarly, if you want to define for cot theta, you move on the edges of your hexagon. For cot theta, cosecant divided by secant. Next, if you want to define this cosecant theta, the other two, that is secant theta divided by tan theta, right? So using this hexagon also we can remember. Other than that, what I will suggest you people is to remember only these two values, that is sine and cos. Opposite by hypotenuse and adjacent by hypotenuse. These two formula if you remember. Simply tan is nothing but sine by cos. Cosecant, secant and cot are reciprocal to sine, cos and tan respectively. Is the easier method. So this is how we can remember the trigonometric ratios, which is helpful for solving exercise 8.1. Thank you. For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.